Alrighty, for this problem, we're going to be looking at three charges on a line. At the origin, I have a negative 12 microcoulomb charge, so we can't forget in problem solving to change that to coulomb. I have a positive 7.5 microcoulomb, and I have a negative 4 microcoulomb as well. Between the negative 12 and the 7.5, that distance is 45 centimeters. And between the 7.5 and the 4 microcoulomb is 15 centimeters. And the question becomes, what is the force on our center charge? So what's the net force in the 7.5 microcoulomb charge? First thing we do, set up our Coulomb's law expression for each charge pair. So K, negative 12 times 10 to the minus 6 coulomb, 7.5 times 10 to the minus 6 coulomb, divided by my distance, which must be in meters, so 0.45 meters squared. And when we do that, we get a 4 Newton force. It is negative technically because of this guy, meaning it's an attractive force. What's more important to me when I'm working these problems is what direction does attractive mean? Well, since this is the charge that I'm paying attention to right here, he would get pulled in that direction. So that 4 Newton force is in that direction. Then we set up our second charge pair, which is, again, K, and the same 7.5 times 10 to the minus 6 coulomb. And this time we've got a negative 4 times 10 to the minus 6 coulomb. The distance was 15 centimeters, so 0.15 meter squared. And when we solve for the force, we will get a negative, because of this, 12 newtons. But again, what's important to me is exactly which direction does that attractive negative force represent. There's my target charge. He would get attracted that direction. So my 12 Newton force is in that direction. I have a 12 Newton force in this direction. I have a 4 Newton force in that direction. Net force on the 7.5 microcoulomb charge, 8 newtons. Whoops, I really don't need to write it again. I think you got it once. In the positive x direction. So anytime you have 3 charges on a line, like we did up here, 1, 2, 3, or even 4 charges, 5 charges, it doesn't matter. Take each pair of charges, run Coulomb's law with it, get the value of your force, decide on direction, sum everybody up at the end, decide on the net direction of your forces after that. Alrighty, hope that helps.